Hello everybody. In last video we have rectified the problem in this portion of the geometry, that is the 9 degrees bend, and we have created the 5 parts and by decomposing geometry into this single part, and remaining parts I can show here. So right click here and show all bodies, and our remaining parts, they are decomposed already. And total bodies we have right now 23 bodies, and now we can move on to the meshing software. And before that I want to show you that how you can display these colors with name selections. The option is here where you can set the color by body color, by thickness, by geometry type, name selection, by shade topology. Also we have by connection. These will be displayed, and if you want to display vertices or not, it's your choice, so you can display them if you want. And also if you don't want to display any sketch here, so right click here and hide sketch. Simply do it and hide all sketches one by one, and they will be hidden from the view on the screen. And this may be useful when you want to output the picture file for your thesis or for your presentation. And also you can, if you click here, that is this axis option, you can display them here also. This will display model or not, and this is the display of points. So these options are there. And now we move to the meshing software. Double click here, this will open the meshing software. And I'm just going to delete this Mutlizone option from here. And now see, I right click here and just clear data from this Ansys meshing software. And now for hexa meshing. So first question may be come in your mind that what's the purpose or the benefit of creating hexa mesh. There are multiple benefits. Number one is that hexa meshing will require, or you are going to create the less number of nodes than the tetra mesh. So it's almost a ratio of 4 to 5 times less cells you will have in the hexa meshing as compared to tetra mesh. And less cells means that you require the less resources in terms of the CPU, in terms of RAM, and as well as you require less time to solve this case or any case with hexa mesh. So this is a benefit, and less number of nodes, less time, and everything. And resolution is in your control. You can precisely control where you want to have the refined mesh. The downside is that we need the various operation to decompose geometry, which is pretty maybe difficult or maybe cumbersome, especially in the Ansys meshing where we need to divide geometry into multiple parts. While in the ICM CFD, we have to divide the blocking not on the geometry but on the blocking side. So it may be much easier. But anyhow, for hexa meshing in any software, it requires a lot of work. So this is the downside. Now let's start with this all thing here. And as I told you earlier, you can create hexa tetra mesh with the information layer, and accuracy level might be almost similar to the hexa meshing if you refine the mesh in the important regions. And now we are going to insert the method. Now there is a question that we should be putting the sizes on edges where we can control the boundary layer mesh, and for that purpose we can control the y plus value. So first we should put sizes, or we should first put the method. In my experience, if you put the method first, the sizes may not work because the method will enforce its own background working on the sizes. And in that case, this will not work or not to up to your expectation or your requirements. So what is my practice is that I put the sizes first on the edges, and then I put the method, which is Mutlizone method for this case. So therefore we start with the insert sizing, and because we are putting sizing on the edges, so I will choose edges which are parallel to each other. For example, these edges on the outermost concentric cylinder, and only put sizes on the one side. Remaining inside the volume, all parallel edges will have the same meshing because of the algorithm of Mutlizone. So we have chosen these 4 edges, and from the type we are going to put the number of divisions, and number of division I'm going to put at least they should be 14 to 20. So let's say we start with the 20. And now one more thing is that we have the wall condition on this area, which is seen here, and also we have the wall condition here. So the defined mesh should be in the region of this wall as well as this wall. So we need a double grading on the both sides to define the mesh and that boundary region, which is on the upper pipe and on the small pipe. And therefore I'm going to use the biasing which is on the double side. And behavior I'm going to put as hard. Hard means that the whatever things the Ansys meshing thinks is the best for you, they will be overridden by your choice. So even if the Ansys machine thinks that this sizing or method is better for you, so with the soft it will apply its own strategy and will apply your method only when it thinks okay. But once you tell it that make it hard, it means that you want to implement by any means, so it will do it. And biasing I will be using from the 2 sides. So 2 sides refined mesh, and that is here. So this will be the refined mesh on the sides, and then the center mesh will be coarsen. And my experience says that the bias factor, which is not a ratio of the meshing elements you normally see, the bias is a different factor, and 10 was good for me. And I can see the mesh is going to be refined in the center, so I need to check it and change it to this method. And now I have the refinement on the sides, on the walls, and coarse mesh in the center area. And you can click on generate. And now I'm going to put the edge sizing on the other edges also. So, and for the time being, I'm going to hide this mesh from here. So from here you can show mesh or hide mesh. And I will be quickly putting the sizes on these edges as well, these 4 edges. So I will be doing same thing here. And you can also right click here and you can put the sizes if this give you option. And if not, then you can go back to that option from the right click on the mesh and do it. And if you don't select anything, you can also put insert the sizing here as well. So there's no need to right click on the mesh, and you can choose these edges again and apply here. And again I'm going to put instead of element size, I'm going to put the number of divisions, and I would be using around 14 divisions here. Again the behavior is hard, and this time I'm going to use the biasing on the one side, and I need to check that where it is applying. So one edge is towards the wall, second edge is towards the interior. So I have to reverse the bias. So for this edge and plus for this edge. So because they are pointing the more nodes towards the inner side, and after applying the reverse bias, they will change direction of edge or the meshing towards the outer side or towards the wall. And then I'm going to put the sizing on these edges, which are these edges on the periphery of the circle. Insert sizing and these edges, and you have to keep on pressing the control key and select these edges with the help of the left mouse button. And we selected all these edges, 12 edges, and I'm going to put the size number of divisions as 10, and I would be making 10 as a soft and 10 divisions here. And there's no need of the biasing because I need the uniform mesh across this whole periphery of this circle, and click on generate. And now you can see that this is happening. So I'm going to make it hard and again generate mesh. And this is the difference of that all thing. So we have put our size, all sizes, and right click on method, insert method, and choose all bodies, select all, and apply. And I will choose Mutlizone, and source and the target selection is automatic. Just leave it, all default options, and click on generate. And the meshing software has just closed. Double click here again and see the mesh. So we have this problem here, and I want to see the where problem is coming. So we have these all 4 edges, we have these all edges here, and they are having the same size perfectly. And so maybe you can zoom, and maybe they are small edge, we have left something. No, everything is perfectly fine. Then maybe we can choose from the this source and target surface. Maybe we choose just the source faces manually, and then try again and click on generate. And now you can see that this has created this mesh perfectly. And if I change this back again to the automatic, and again see what happens here, and you can see again the same issue. So again I will change to the manual and choose these faces as a source faces, and again apply. And why I'm doing this thing, I want to just make sure that you don't make any mistakes. So I am just going through everything is possible which can happen inside the Ansys meshing, and then how to tackle that thing. So maybe this video is a bit longer as if I just come and just said the things I know which are working perfectly, and show you that this thing has worked, and we have got some mesh, decent mesh, and then that's all within 2 or 3 minutes. But that's not the purpose of this whole course. I want to give you whole idea that what can go wrong, and then how to tackle that thing and make things correct here. And at this point we have done with the meshing, but I just want to show you one more thing, is that if I change the sizing after the put sizing after the Mutlizone, then what will happen? So I'm just deleting these sizing from screen, and I will be deleting all data we have generated so far, and I will put sizes on all edges as we did previously. And I will not show in the video, but I will do that thing, and you will see in the screen that in a tree outline this is after the Mutlizone. And you can see that almost the things are almost same, but I can observe one thing, that mesh is refined too much here. And secondly, we have this biasing on these edges, which we put them as a uniform. So maybe you can say this is soft, so we can put it hard, and okay, we can generate it again. But even with the hard option, this is not doing it. And with the previous thing that the Mutlizone method was on the last and sizing were the first one, without any forcing the behavior to the hard, it was creating uniform mesh because we didn't give any bias here. So it should not be creating any bias on these corners. And so this is happening is if you put the Mutlizone first, method first, and then the sizing, this will happen. So therefore I recommend that you should put sizing first and then this option, Mutlizone option, on the last one. And even putting the behavior as a hard, and then we again created a mesh, but it's still same thing here. So therefore I will revert back to the scheme that the method should come after sizing. And now you can see that the mesh is now perfect. And one more thing, just a comment, and right now the mesh is final, but it's just a comment. This region, which you can see here, this square region, either the size of mesh on this edge, these edges are is too large here, or maybe we have put more sizes on these edges, or maybe this square is very small here. So I will suggest that either you increase number of nodes here so that the size, this size and this size, they are matching, this square and this square, they are matching. And if you want to increase size of this square, the inside square of this geometry, this can be done from design modeler. And for that, if you remember, we have defined this on plane number 4 and sketch number 6. And you can put the, let's say, value from 0.18 to 0.2, so it's a change of 0.02 meters. And maybe you can try a 0.22, difference of 0.04, and click on generate. And now you can see the size of this square is changed from that size 0.18 to 0.22, and this size is somehow bigger. And now I will open this Ansys meshing from again from meshing tab, and this will open the new geometry file inside this meshing application, and it just requires update of the mesh. So click on generate, and it will start to generate with the new geometry. And the new geometry is changed in the dimension of this square from 0.18 meter to 0.22 meters. And now you can see the size of mesh across this concentric cylinder and this square cylinder, they are almost matching. If I take an example of this element and this element on this side. So now this is all about the meshing in Ansys meshing for this case with the Mutlizone meshing and this A-sizing. And then I will discuss about some few things in the Ansys meshing, then we continue with the Fluent and solve this case with some boundary conditions.